Hello and welcome back to the 2015 AP Calculus exam. So for question number 3, we're talking about Joanna. Now Joanna is going out for a jog. But before we go into the problem, I want to take a look at this table right here. That gives me a lot of information already and kind of what I should be anticipating for the problem. One, it's telling me that we're given velocity. Now velocity, we know, is the derivative of our position graph. So right away I'm thinking I'm probably going to have to do a Riemann sum or a trapezoidal type of sum somewhere in this problem right here. So let's go ahead and read this. Joanna jogs along a straight path and it says about 40 minutes. Her velocity is given by a differentiable function. So basically it says that it's a derivative. It means there's no hole, there's no gaps. He's not being abducted from aliens and being dropped somewhere else. Selected values of the velocity and time is given above. And of course time is in minutes and the distance or the velocity or distance here is going to be in meters. The first question says use the data in the table to estimate the value of v prime of 16. So they're looking for an estimation of acceleration at 16. And that's what this is kind of going here. So to get the acceleration, v prime of 16, now it is an estimate, so we're going to go approximately. And we're going to use the average rate of change. Because this is not a function, I can only use AROC, not IROC, not the instantaneous rate of change. Now, time to 16 occurs somewhere between 12 and 20 minutes. So when I set this up, I am going to be looking at the change in the velocity of 20 minus the velocity of 12 over 20 minus 12. Now this is non-calculator, so we got to do the math here. So the velocity of 20 is 240 minus 200 over, and 20 minus 12 is just 8. And I can simplify this, 40 over 8, and this becomes 5. But now let's talk about units. Now I know it's acceleration, but I do like to talk about the units here. The top is my velocity. This I know is meters per minute. The bottom is in minute. This is my change in minutes. So this is going to be 5 meters per minute squared. Make sure you include the units on these. And this is going to be worth a whopping 1 point. But you need to show your work. You want to show this. The AP, if you don't show this, how you got your answer, you will most likely not get any credit on the AP exam. Part B says, using the correct units, explain the meaning of this integral in the context of our problem right here. Approximate this integral using the right Riemann sum with 4 subintervals. So there's our Riemann sum right here. So let's talk about what the meaning of the integral means first of all. So let's talk about this. The integral from 0 to 40 of the absolute value of velocity dt. So if we think of units, my velocity is meters per minute, dt is in minutes. So this is going to give me a distance, the distance that we travel. Now, without the absolute value, we would always say that this would be our net difference, net distance, or displacement. But what the absolute value does, it takes any negative distance and makes it positive. So this is our total distance. So this is the total distance Joanna travels over the 40 minutes. And we're going to write that down. Travels in the 40 minutes. Next, now we're going to answer the question. Using a right Riemann sum with 4 subintervals indicate on the table. So we want to approximate this integral right now. And they do tell us to use a right Riemann sum, so I'm going to go and do that. So starting at 0, our times are 12, 20, 24, and 40. Now remember, we are using absolute value, so everything here is going to become positive. We're going to use a right Riemann sum, so between 0 and 12. 12 is on the right, so my first, from 0 to 12, we're going to use the model for 200. Doesn't have to be perfect. And then from 12 to 20 is 240. Again, goes up. There's 240. And then from 20 to 24, we're going to use this negative 220. We're not going to go negative because, remember, we're looking for the absolute value of it. So this goes up to 220. And then our right side was 40, and that's going to be our 150 right there. And now we can say, therefore, we can say the area from 0 to 40 of the magnitude v of t dt is equal to, and we just have to find out this area. This is going to, now write out your integral. Whoops, not going to be an equals though. It's going to be an approximate, remember, because we're approximating. And this first one is going to be 12 by 200 plus 8 by 240 plus 4 by 220 plus, whoops, that's what, 16? Wow, 16 times 150. And make sure you put your units in here. Meters. So that's the total distance that she travels. Do not simplify it. You can leave it alone. Now, if you do simplify it, though, you get 7,600 meters. But you don't have to simplify this. So how many points would this be worth? You would get 1 point for your explanation. You would get 1 point for your Riemann sums. And you get 1 point for your answer right there, your approximation. So we're already up to 4 pointers. Pretty good. All right, Bob. What about Bob? Bob is riding his bicycle on the same path for 10 minutes. Bob's velocity is modeled by our equation right here, where t is measured in minutes and b of t is measured in meters per minute. Find Bob's acceleration. Well, as we talked about above, acceleration is just the derivative of velocity. So we want to get b prime of t, which is going to be 3t squared minus 12t. And then we get b prime of 5. It's going to be 3 times 25 minus 5 times 12. I don't know what that is. And you can leave this alone, but get your right units in here. This is going to be meters per minute squared. I know that because it's going to be an acceleration. Now, you don't have to simplify it. You can leave that alone. So that would be worth 1 point for getting the derivative and then 1 point for your answer. Now, if you want to simplify this, you can. You get 15 meters per minute squared. You don't have to simplify that. And the last question says, based on the model B from part C, find Bob's average velocity. Now this is a tough one. Average velocity. This is not average rate of, this is our favorite. This is our average value because for Bob, B of t is our value. So velocity for Bob is our value there. So we're going to look for the average value. So what's our fave? That's just 1 over b minus a, from a to b, f of x dx. So for us, 1 over 10 minus 0. From 0 to 10, we get t cubed minus 6t squared plus 300 dt. And you're going to get 1 point for setting that up. So we're going to get 1/10. And I'm going to go ahead and integrate this one. T to the 4th over 4 minus, this is just, what's that? 2t cubed plus 300t from 0 to 100, from 0 to 10, and that becomes 1 over 10 times, I don't worry about the zeros, they're all just going to go away, but I get 10 to the 4th, which is 10,000, over 4, minus 2 times, whoops, that should be 10,000, there we go, one more 0, minus 2 times 1,000, plus 300 times 10. And this is an average, don't simplify, this is an average velocity, meters per minute, right there. So how much would each of these parts be worth? 1 point for your integral, 1 point for the antiderivative, and 1 point for your answer. Do not simplify this. Alright, that was a pretty easy question. You should all get that one right. Alright, I'll see you later. Come back for question number 4 in just a few moments. Bye.